stage, it seemed to me. Makeup on their faces, actors took their places next to me.
Okay, we're going to finish our pre-calculus review today. Exciting, because we can actually start calculus next day. So I would say what we're doing today is of minor importance, not great importance. You know, the stuff we did last day, for example, is way more important than this. But these things will come up from time to time, so it's a good review. You've done all of them except perhaps the last thing before. So the first thing is operations on functions. You have two functions here. You have f of x, which is 3x minus 1, and g of x, which is x squared minus 2x, and we want to find the following. First of all, f plus g of x. Well, f plus g of x is the same as f of x plus g of x. So in other words, all you have to do is take f of x, which is 3x minus 1, and add it to g of x, which is x squared minus 2x. Then just have to combine the terms. There's only one x squared, so I'll put that. There's a 3x and a minus 2x, so you end up with plus 1x, or just x. And then you have a negative 1, and there's no like term for that either. So that should be your answer. Okay, this one's a little different because it's not g minus f of x, it's g minus f of 3. So there's two ways you can do this. One way you can do it is start by doing the same thing we just did. You can think of this momentarily as just being an x here. And you say, well, g minus f of x is the same as g of x minus f of x, which means we have our g of x, which is x squared minus 2x. It's very important you put it in brackets right here, minus f of x, which is 3x minus 1. And then again, we combine like terms. We have x squared, oh, no other x squared, so we're done that. You have negative 2x, take away 3x, which is negative 5x. And then you have this negative 1. But remember, it's take away negative 1, which is plus 1. So that's great, and that's what the answer would be if it was g minus f of x. But it's not g minus f of x, it's g minus f of 3. So you know what you do now? You plug 3 into these x's. So you get 3 squared minus 5 times 3 plus 1, which means 9 minus 15 plus 1. 9 minus 15 is negative 6 plus 1, negative 5 should be your answer. Okay, there's also another way to do this. I'm going to put or. The other way you could do this is you could start by doing g of 3 and then take away f of 3. So you could go straight to plugging the input in right away. So g of 3, that means 3 squared minus 2 times 3, and maybe I'll put that in brackets, and then I'm going to minus f of 3, so I'm going to put 3 into f. So that means 3 times 3, 3 times 3, and then minus 1. Squish, squish, squish. Okay, if you do that, you get 9 minus 6, which is 3, and then 9 minus 1, which is 8, so you get 3 minus 8, which is negative 5. So either way works. I prefer probably the second method. If I know what the input value is, I prefer just to plug it in right away. But the nice thing about doing it this way is, if you then were asked, okay, if g minus f of 3 equals negative 5, what's g minus f of 10? If you're doing it this way over here, you'd have to do the whole process over again. If you're doing this method here, you could go straight down to here, and you could just plug 10 into here. 10 squared is 100, 5 times 10 is 50, 100 minus 50 is 50, plus 1, 51, I'm done. Whereas here you'd have to do the whole process over again. So it kind of depends on what question you're asking, whether you should use the first process or second process. But you can use them both. Okay, GG, I love it. GG of x means g times x. And g times x is the same as g of x times g of x. So all we're going to do is take g of x, which is x squared minus 2x, x squared minus 2x, and we're going to multiply it by another g of x, x squared minus 2x. Okay, you're going to distributive property here, expand, mountains and valleys, whatever you want to call it. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. Negative 2x times x squared is another negative 2x cubed. Negative 2x times negative 2x is positive 4x squared. Combine the middle two terms, and you are done. You could factor out an x squared here, but I think for the purpose of this question, we're done. And finally, this one, g divided by f of 0. Well, again, g divided by f of 0 is the same as g of 0 divided by f of 0. And just like we did up here, since you know the input, you could start by doing this method, doing g divided by f of x, and then plug it into it. But I think I'm just going to do it this way, just to make it a little bit faster. So what we need to do is do g of 0. So we're going to plug 0 into g. So I get 0 squared. Why don't I write this? 0 squared minus 2 times 0. Then I'm going to do f of 0, which means 3 times 0 minus 1. So on the top, you have 0, take away 0. Oh, we just have 0. On the bottom, you have 3 times 0, which is 0, take away 1, which is negative 1. 0 divided by negative 1 is 0. We're finished. Okay, moving on to composite functions. These are functions of functions, applying one function to the results of another function. And we have to look at the domain of both functions. So if we have one function f of x, which is 2x squared minus 1, and another function g of x, which is 3x, and we want to know what f of g of negative 1 is. Do you remember what we do? You start with the innermost function. So the first thing we're going to do is figure out what's g of negative 1. So we can do that. We plug negative 1 into the x here. So we get 3 times negative 1, which is negative 3. So now what you want to do is you want to take f of, well, you know what g of negative 1 is. G of negative 1 is negative 3. So you're taking f of negative 3. Well, we can do that too. You plug negative 3 into the f. So you get 2 times negative 3 squared minus 1, which is 2 times 9, 18, minus 1, you get 17. Okay, this is just another way of writing the same thing. This is g of f of negative 1. So it looks very similar to this, almost the same, right? But what's the difference? The order you're doing them in. The first thing you have to do, again, is the inner function. So you have to do f of negative 1. So let's do that first. F of negative 1 means negative 1 gets plugged in to the x's here. So we have f of negative 1 equals 2 times negative 1 squared minus 1. Negative 1 squared is 1, times 2 is 2, so you have 2 minus 1, which is 1. Okay, now we want to know what g of 1 is. So we're going to plug 1 into g, and you get 3 times 1, which is 3. Notice you do not get the same thing here. Sometimes you will, but in this case you did not. So the order matters, where it's f of g or g of f. Okay, the next one is f of g of x. So there's no input here. So basically what you need to do is you need to take this function, the inner function, g of x, and you need to plug it into f. So what that would look like is I'm going to write down f, but what I'm going to plug into it is g of x. So everywhere I see x here, I'm going to put the g of x, which is 3x. So right where this x is right here, I'm writing 3x. So we got 2 times 3x squared, right? That's squared there, minus 1. Okay, so first of all we have to do the 3x squared. That's the same as 3 squared and x squared, so 9x squared, then minus 1. If we multiply by 2, you get 18x squared minus 1. Last one similar. This time you have f of x. What does that mean? That means you're going to take the inner function f of x, well, here's f of x right here, and you're going to plug that into f. Weird, right? So wherever you see an x here, you're going to put the f of x function, which is 2x squared minus 1. So we're writing f of x. We're taking f of x, which is 2x squared minus 1, and plugging it into the x right there. So I get 2, oh, here comes an x. What am I writing there? 2x squared minus 1. Then I have to square it all, and then minus 1. Oh darn, this is going to be a little bit of work here. So 2 times 2x squared minus 1 means 2x squared minus 1 times another 2x squared minus 1. So if you picture that, you're going to have 2x squared times 2x squared, which is 4x to the 4th. you're going to have 2x squared times negative 1, and then negative 1 times 2x squared, you're going to end up with negative 4x squared. I hope you can picture that. Negative 1 squared is plus 1, and then we have a minus 1 here. You got to do the distributive property, so you get 8x to the 4th minus 8x squared plus 2 minus 1. Combine those last two terms, you get 8x to the 4th minus 8x squared plus 1. And we're done. Okay, more functions. We're looking at inverse functions now. Inverse functions undo each other, right? If I have a function like x plus 3, what would the inverse function be? X minus 3. Just undoes what you already did. So we're going to find the inverse of these functions here. Do you remember how to do it? There's a fairly simple process to do it. The first thing you do is, if it's written f of x, you just change that to y. That should be okay, because you've been taught before that f of x basically means exactly the same thing as y. Then what you do is you reverse the y and the x. Wherever you see y, you put x. Wherever you see x, you put y. I'm not going to write all the steps out in words, because I know you have seen this before. And now what you do is you isolate the y. You got to get the y all by itself. Well, to get the y by itself, we better move this negative 6 first of all. We'll move that to the other side, so we get x plus 6 equals 3y. And then the last thing you're going to need to do is you're going to need to divide by 3. So I get x plus 6 all divided by 3 equals y. Another thing to do, it's a good idea I suppose, is to change your y, change it back to not f of x, but f inverse of x. So we get inverse f, or f inverse of x, equals x plus 6 over 3. Okay, let's just test this, see if it's, you don't have to always do this, but just to show you how this works. Let's say that we plug 2 into the original function. So you would have f of 2, which equals 3 times 2, which is 6, take away 6, and you get 0. So how would we test this to give a pretty good indication we've done it right? You would take the output of here, you'd plug it into this one, and you should end up back with what we started with, which was the 2. So let's try. If we take inverse f of 0, we would have 0 plus 6, which is 6, divided by 3 equals 2. And it worked. What we started with here is what we got there. So this second function undoes the work of the first function. Okay, one more of those. So our steps were change f of x to y. Then everywhere we see y, we're going to put x. Everywhere we see x, we're going to put y. Now we have to isolate the y. The fraction here is a bit of a drag. Why don't we get rid of the fraction? So why don't we multiply both sides by y minus 5, right? We're going to multiply this side by y minus 5, and we're going to multiply this side by y minus 5. Why do we do that? Because that gets rid of this. So what we have here is y minus 5 times x. Okay, let's expand that out. Distributive property here. So you get xy minus 5x equals negative 2. That's the only thing you have over here is negative 2. Now, we're trying to get this y all by itself. It's getting easier to do that. Let's move this negative 5x over. So you get xy equals 5x minus 2, or negative 2 plus 5x if you want. And the last thing you need to do is you need to divide by x. So we get y equals 5x minus 2 all divided by x. And again, it's a nice touch to put inverse f of x equals 5x minus 2 over x. And that should be our answer. Again, if you're not sure, you could definitely test it out. Should we do it? Why not? Let's put something easy in here. What would be an easy one to put in here? How about 6? I think 6 is a good one, because if we put f of 6, you'd get negative 2 over 6 minus 5 is 1, so you just get negative 2. So what does that mean? That means if we plug into the inverse f, if we plug negative 2 into it, we should end up with 6. So let's see if it works. 5 times negative 2 is negative 10, minus 2 all over. There's another x, so we're going to put negative 2 again. So we get negative 10 minus 2 is negative 12 over negative 2, which equals 6, and that's exactly what we said it wanted to equal. It worked. Looks pretty promising that we have the inverse function right here. Okay, now we're going to find the inverse of a graph that's already there. So there's a couple ways you could do this. One way, and it's the way I like to do it, is I look at individual points. like nice pretty points, right? Like this one, and that's a good point, and this is a good point, and that's a good point. And what I do is I switch the points, like the x and the y values. So this point here is negative 4, 0. Since that's negative 4, 0, I know in the inverse it's going to go through 0, negative 4. You just switch the order. 0, negative 4 right here. This one's negative 3, 1, which means in the inverse it's going to go through 1, negative 3. This one's 0, 2, which means it goes through 2, 0. And this one's 5, 3, which means it goes through 3, 5. And with those points, I can certainly draw the inverse right here. Not perfect, but not bad. There's also another way you can do it. I find this more difficult. I could have drawn a line from corner to corner. Do you remember the equation of that line? The equation of that line is y equals x. And it's always going to be the case that the inverse function will be a reflection over across this line. So I find that difficult to do, but what I could have done is just drawn that dotted line, taken this blue curve and said, if I reflect it over this dotted line, what would it look like? And boom, that's what it would look like. But I'm just not very good at doing that, so that's why I like taking my points and doing it this way. Just to help you out with this for later, if you're looking back, this is my f of x, and this one here is my inverse f of x. And then this is my y equals x, the reflection line. Okay, the last thing you probably haven't seen before, it's not a huge deal, but I think it does pop up a few times in the course. It's when we're talking about intervals. So remember, we've already talked about intervals a couple times. We've looked at things like, the interval from negative 3 up to 2. And I'll put it curved like this. What does that mean? That means the same as negative 3 is less than or equal to, let's say it's the domain, so let's say x, which is just less than 2, right? These are two ways of showing the same thing. Now we're going to show you a third way, which I'm not as big a fan of. I find this a little bit confusing. Thankfully, it doesn't show up too much in the course. So there's 3 steps to doing this. One is you're going to use the endpoints. So here's my endpoints, 2 and 10, right? You're going to use your endpoints to determine the midpoint. Then you're going to determine the distance from the center to the endpoints, and you're going to determine the inequality type. So let's do a little sketch here to help us out. Basically what we're talking about, if we're talking about this interval 2, 10, is we're talking about, and they're square brackets, so it's from 2 inclusive up to 10 inclusive, 2 and 10, and everything in between, right? Okay, so the first step here is we're going to figure out the midpoint. Now, to get a midpoint, you could just look at it and ask yourself what's right in the middle of 2 and 10. But if you ever have troubles doing that, the other way you can get a midpoint is just take the average of them. So I go 2 plus 10, divide by 2, it's 12 over 2. The midpoint is 6, so I'll just put a 6 right there. That's our midpoint. Okay, the next thing I have to do is I have to find the distance from the center, that's 6 from the midpoint, to either one of these. So, again, you could just look at it and go, well, from 2 to 6 is 4, and 6 to 10 is also 4. Or if you have troubles with that, the other way you can do it is you can take the absolute value, because our distance is going to be a positive value. You can do the absolute value of 2 minus 6, or you could do absolute value of 6 minus 2, or you could do 6 minus 10, absolute value, sorry, or you could do absolute value 10 minus 6. Whichever way you do that, you get 4, right? 2 minus 6 is negative 4, absolute value of negative 4 is 4. Either way you do it, you get 4. Okay, so what we've learned here by doing this is we found that in relation to 6, all the points we're interested in are at most how far away from 6? They're at most 4 away, right? 2 is 4 away from 6, 10 is 4 away from 6. All the other points we're interested in, all these, they're all less than 4 away. So how am I going to write this? I'm going to say all points that we're interested in are 4 or less from 6. So what does that look like? That looks like that the point take away 6 is less than or equal to 4. If we take any point on here, We want to get the distance, so just like we did up here, to get the distance you subtract and take the absolute value. So that's exactly what we're doing here. Any point, call it x. Okay, I'm just going to arbitrarily pick any point right here, for example, and call it x. If I want to know the distance between that point and 6, I subtract x minus 6, or 6 minus x, by the way, take the absolute value of it, and we know it's going to be less than or equal to 4, because they're all within that distance from 6. Kind of complicated, right? Okay, let's do one more of these. So what we're actually talking about here is a little bit different. We're saying it either goes from, we're rather interested in all the points from negative infinity up to 3. So I'm going to put 3 right here. And not inclusive. So what kind of dot should I put here? We should put an open dot. And it's down to negative infinity, which is this way. Okay, or they're greater than 15. Not including 15 all the way up to infinity. So it's going to be a little bit different. You can probably guess what that's going to mean to the sign here, but let's go on. So the midpoint, first of all. To get the midpoint, if you can't just figure it out by looking at these, you're going to get the average. So you can go 3 plus 15 divided by 2. That's 18 over 2, which is 9. So I'll just put 9 right in the middle here. Now I need to get the distance. Okay, again, to get the distance, you're going to do the absolute value of 3 minus 9, or the absolute value of 9 minus 3, or the absolute value of 9 minus 15, or the absolute value of 15 minus 9. It really doesn't matter. I'll do the absolute value of 9 minus 3. You get the absolute value of 6, which is just 6. And that's true, right? The distance from 3 to 9 is 6. The distance from 9 to 15 is 6. Now, what's true about all the points we're interested in? Are they all less than a distance of 6 from 9, or more than a distance of 6 from 9? They're all more than 6. 6 only gets you to 15. We're interested in the points further away from that. 6 only gets you to 3. We're interested in all the points further than that. So all points are more than 6 from 9. Away from 9, I guess might be a better way to say that. But they're all more than 6 steps away from 9. So how would we write that? Again, if you take any arbitrary point, like this one right here, let's say, if you wanted to know the distance of that point from 9, you would go absolute value of x minus 9, or absolute value of 9 minus x if you want, but usually write it this way. And we're saying that point is more than 6 away from 9. So this is your answer. You would not put the line underneath, of course, because these are open circles and not closed circles. Okay, everyone, we've made it. You have reached the end of our pre-calculus review. We're ready to start calculus.